Hi guys, today we're going to take a look at page 11 of the Unit 8 Classwork packet, and we're going to look at example 5, which combines everything that we've learned thus far about a rhombus into a single problem. So I've drawn the diagram, and I've actually put the information they gave me on the diagram itself, okay? But now I want to go a little bit further, and I want to, before I even look at what the heck they're asking me for, I want to see what other information I can fill in. Okay, first things first. I know that a rhombus has 4 congruent sides. So that means, guys, that every single side here is actually 34. Isn't that super awesome? Then I know that this whole diagonal is 38, so that means that each piece is actually just going to be half of 38, which is better known as 19. Dealing with angles now, I know that each one of these right here is 90 because the diagonals are perpendicular. Looking at the other angles inside here, I know that rhombi have angle bisector diagonals. So this is 34. That means so is this, this, and this. Then, in order to find each one of these, what I would do is I would use triangle sum theorem. So I have 90 and 34. That together makes 124. Subtract from 180, and I get 56. Because the diagonals are angle bisectors, that means I have 56, 56, 56, and 56. So guess what, guys? That's enough to fill in all the angles you see there, and to fill in the vast majority of the sides. Okay? Let's actually go through, stop here for a second, and let's go through and fill in everything we actually know. Do we know WZ? Yes, we do. It's 34. Do we know VY? Yes, we do. It's 19. Do I know ZV? Not yet. I'm going to do that in a second, okay? So hold your horses there. Do I know ZX? That's going to, again, be a Pythagorean Theorem in a moment, so hold on. Do I know WXZ? WXZ. Yes, I do. It's 34. Do I know WVZ? WVZ. Yes, I do. It's 90 degrees. Do I know ZYW? ZYW. Yes, it's 56. Do I know XYW? XYW. It's also 56. All right. So I actually found, in the span of about, what, a minute, I actually found 6 out of the 8 points for this particular problem. Yay! Now let's deal with the irritating part, which is the Pythagorean Theorem. What I'm going to do, guys, to find VZ, I'm actually going to redraw this triangle right here. All right? So just bear with me for a moment. There's a right angle. There's 19. And over here is 34. I'm looking for this side. So I have to use the Pythagorean Theorem. They gave me a leg and a hypotenuse, so I'm not plugging in for A and B. Instead, I'm going to plug in for A and C. Let's show how that works. 19 squared plus B squared equals 34 squared. So that's 361 plus B squared equals, I actually don't know this one memorized. I apologize. Shame on me. 9. All right. 12, 1, 10. So that's going to be 6, 5, 1, 1, 11, 56. Then, to solve, I would subtract 361 from both sides. So that's going to be 5. I got to borrow here, right? 0. So that's going to be 9, and then 10 minus, so 795, right? And so B would just be rad 795. I'm not even going to try to simplify that, okay? So don't even worry about that. But then, because this piece right here is actually twice as long, it would just be 2 rad 795. I'll lower that so you guys can actually see all the work, all right? Now, if you're actually given a calculator, of course, you'd probably just want to simplify that by just, putting it in the calculator and get like to the nearest tenth or something, okay? On the EOC, chances are they probably would give you a calculator for that kind of problem, but they would also give you a radical. So don't be surprised if it comes up either way. But the bottom line here is a strategy you might want to use. Ignore what they're asking you for, Simply find everything you can, and that's going to make it much easier to just grab the answers from the diagram and go from there.